Hi everyone, welcome to Netgate Chemistry. So initially we studied about the charge contraction theory and two applications of it. So today we are studying about the last application of our charge contraction theory, and also we'll be having a little bit knowledge about the mixing of atomic orbitals. So the third applications of our charge contraction theory was non-existence of some compounds. So the non-existence can be because of two reasons. Okay, one being unavailability of vacant orbitals, and the second being the absence of charge contraction. Okay, these can be the two reasons for the non-existence of any compound. So for this unavailability of vacant orbital, for example, in some cases of our nitrogen, oxygen, aluminium, some compounds of these they do not exist. For example, NF5, AlCl3 exists, but AlCl5 does not exist. Your NR5, R is your N-alkyl group. Your OCl4, all these type of compounds, they do not exist. And second is your absence of charge contraction. If there is no charge contraction, then the compound cannot exist. For example, XCH6 cannot exist. XCF4 can exist, but XCH4 cannot exist because why? Because in that case F was, see here, F was electronegative, so it was taking the electron density towards itself, but H cannot take the electron density towards itself, so there cannot be the possibility of any charge contraction here. So that's why XCH4 cannot be formed, or your IH3 cannot be formed. Okay, these type of compounds, they cannot be formed. So this is your last application of charge contraction theory. Okay, so now we'll be having some idea about the mixing of our atomic orbitals. Okay, so okay, so mixing can also be of two types. Okay, mixing can be like if okay, mixing of atomic orbitals of same atom having different energies, or second type of mixing can be the mixing of atomic orbitals of different atoms having same energy. Okay, so first look at this case. Suppose A is any atom, and this is your 2s and this is your 2p. Okay, 2p will be having 3 orbitals, 2s will be having 1 orbital. If these undergo mixing, then this type of mixing is called your hybridization, which is our actually next topic. So if they undergo mixing, they will form 4 hybrid orbitals. All of them will be sp3, 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 and sp3. Okay, so first type of mixing is your hybridization, in which the orbitals are of same atom but having different energies. They undergo mixing and form hybrid orbitals. Second is atoms are different. Suppose one is A, other is B. Both have the orbitals 2s having almost same energies, and they undergo mixing just like that. Okay, forms one bonding in one antibonding molecular orbital. Here what happens, one of the orbital has decreased energy and other orbital has increased energy. Okay, this is stabilized one and this is destabilized one, and energy gap between them is increased in this case and decreased in this case. Okay, so I think this much is enough for this lecture. So from next video we'll be starting our hybridization, fresh topic, that is your hybridization, which is actually a hypothetical concept. From that we'll go about types of overlapping, how hybridization takes place, what are the factors which affect hybridization, types of hybridization also, and many more conclusions from that, which is very, very important. Okay, so that's it for this video. Thank you very much for watching. Bye.